Hi, this is Omer, and this is for assignment number 6. And then for this assignment, we are asked to um, use a classification data set, and then I'm using a common example on the corpus of label spam and non-spam emails to predict whether or not the new documentation is spam. For this assignment, I choose the data that can be found here from UCI, Machine Learning Repository, and then I'm using a spam database for that. I use a file spam base names and stem based data. Stem based data is actually data, and then spam based names is the column names and the direction constructor of the file. The first thing that I'm doing is basically I'm importing a bunch of scikit-learn functions and classification models and NumPy, Matplotlib, and everything. And then next thing that I'm doing is basically, since data is available in my GitHub, I'm just importing data. And then this is the data, how it looks like. We can see that all the columns are available. And then our subclass is basically our target variable. So if the subclass is 1, it's a spam, and then if it's a 0, it's not a spam, it's a ham. For better readability under the spam class, I would change the binary values if the email is spam or non-spam to email or spam. For that reason, I'm changing here. It's better readable, and then we can see right here spam emails spams, and then the emails are defined here, and then we change it from the binary to the string values here. And I'm just looking at the data, how many counts is where the rows are available. So 4,601 rows available, and then we can see that each distribution values here. And I'm also looking at the spam data, and then how the spam data looks like it. We can see that 1,813 rows available for spam data, and I can see that what ham data looks like, basically the email data. So 2,788 rows are available for each one, and then I can see that all different values for each column here. And for data preparation, I'm defining y, which is our target variable, and x is our feature variables. And then I'm using 80% for training, 20% for the test data. For that reason, I'm using from a scikit-learn train test split, and then an x is our features and y is our target variables. When we look at it, the train data, we have 3,680 train data for features and the target variables. For test data, we have a 921 the raws observations record. For the target variable, we can see exactly the same raw number right here. And then we do have a 57 features. And then for model interpretation, I will use for possible machine learning methods from the name Bayes, decision tree, random forest, and support vector missions. Now, the first thing that I'm doing basically it's to setting up now a Bayes model from the scikit-learn, and then I'm feeding the model with the X train and the Y train, Y train. Once I set it up, I'm basically predicting an X test. And from there, I do have model predictions. And the next thing is basically I'm putting the results in the data frame, and I have the actual as a Y test and a predictive value. And then you can see it right here, predictive values here, and prediction correction. Basically, if the actuals is equal to predicted, that means you're having true values. So for example, the actual was email, and then we predict that that's email, that's the true values. If the email actuals is email and it predicted the spam values, this is a false. The model actually couldn't predict the correct prediction for that one. And the next thing that I'm doing is basically looking at the accuracy score and the classification report. And here we can see that 0.82%. We do have an accuracy score, and then we can look at the precision values for email and spam, recall, F1 score, and the next thing that I'm doing is basically I'm using the second classification model, which is decision tree, and from scikit-learn I'm using decision tree classifier, and I'm using exactly the same steps that I did for the first model. I'm just training on the X train and the Y train, and then predicting the tree model. And then the following thing that I'm doing is basically I'm putting everything in a data frame, putting the actual, the predictions, and then looking at if the models predicted value, the true value or false value. And then when we look at the accuracy score for decision tree, I'm having 0.93, 93% of the decision tree is model accuracy. And then I'm looking at the precisions and recall for email and spam. They look pretty good actually. Compared to the first model. Next one is a random forest. For random forest model, I'm setting up from the scikit-learn again, and then the exactly the same step, and then train on X train and Y train, and then a prediction is basically on X test. And then next thing that I'm doing basically having all the forest random forest results, having actuals predicted values. We can see that here actuals are here and the predicted values here. When I look at the accuracy score for that is basically having 95%, and this is the one so far is the best model. The random forest model. And then I'm also looking at the classification report, looking at the precision, recall, F1 scores here. The next one is the spore vector missions from a scikit-learn. I'm using exactly the same steps and having a model, and then feeding an X train and Y train, and then predicting on an X test, and then having the results with the data frame. We can have the actuals and predicted values, and then look at to see that each value is predicted correctly or not. And then when we look at the accuracy score on the spore vector missions, and then we can have a 0.66 here. And I'm having email, precision, recall, and F1 scores here. When I compare the four models, I just put in everything in summary data frame. I can see that here clearly that random forest is the best model, and then and the weak models basic spore vector missions, and then decision tree model somewhere is close to the random forest model, but the best model among all the four models is random forest. This is the based on the accuracy rate that I basically calculated, estimated for each model here. Thank you.